Hello and welcome to section 3.4, our series of videos on direct variation. This is a fairly beefy chapter and we wanted to split it up so we didn't have a 12-minute long video. Hopefully get it down to about 3, 4 to 5 minute videos over each thing that we're going to cover. You should have the 3.4 note sheet, which gets folded hamburger style like we talked about in class. And you should be looking at the page that's labeled direct variation with the large boxes facing you. Our objectives as you watch this series of videos is, after watching it, you should be able to identify a function as either a direct variation or an indirect variation, graph functions that represent a direct variation, and finally construct direct variation equations and functions within parameters that we will give you in the problems. So, part 1, definition. What is direct variation? And again, this is the part of your handout you should be looking at to begin with. So, what is direct variation? It's a relationship between x and y, where y equals kx and k does not equal x. So what is direct variation? It's this right here, okay? Y equals kx, that's what we're looking for, all right? Any equation that looks like that, y equals some number times x, and that number does not equal x, so we don't have, y equals x times x, which would be x squared. That's different. We need y equals some number times x. That's a direct variation. Now, that k we call the variation constant. You can write that down. But ultimately, k is m. And if you remember from 8th grade, k is, slope. Correct. K is slope. M is slope. They're the same thing. Y equals mx, y equals kx. They're the same thing. We're going to refer to k because we are talking about direct variation. So we want to talk about the variation constant. But we will build this into talking about what slope is and how they're related. Now, an example, y equals 2x, that's a direct variation equation where k is 2, okay? It's that simple. Anytime you see y equals some number x, you know you're dealing with a direct variation. Now, with a table, and you'll see I kind of had to spruce mine up a little bit just to make it fit, but with a table, what you're looking at here is you want to try and find this point right here, where 0 is for x and is for y. Because one key thing about direct variation equations is they always go through the origin, right? Any equation like this, if you plug a 0 in for x, 0 times anything is going to be 0. So we always expect to see in the table the point 0, 0, the origin. The same thing goes for the graph. Every graph for every direct variation equation needs to go through the origin, okay? So when you're talking about things to look for, you always want to have the origin involved. It always needs to have the point 0, 0 as a part of the function. Now, once you've got this part completely filled in, you want to open your booklet shape and you want to write directly on the back of what we're looking at right now. So on the back for the direct variation page, if you will, that's where we're going to write these next examples. Speaking of examples and non-examples, we're going to look at a table. So here's an example of a table that represents a direct variation. The key thing that we're looking for is that the point 0, 0 is in the table. Okay, input of 0, output of 0. If we see these two zeros next to each other, we know we're dealing with a direct variation. Now, to be totally 100% thorough, we should point out that these need to be linear, but for right now, just trust me, I'm only going to give you linear equations for this. So it's either going to go through the origin or it's not going to go through the origin. And I can tell this one doesn't go through the origin because when x equals 0, y does not equal 0. So that's not a direct variation, and your initial homework problems are going to be that simple. They're going to give you two tables, or they're going to give you a table and say, is it a direct variation or not? If it is, you'll see the 0, 0. If it's not, you won't see the 0, 0. Next is the graph, and we're looking for the same thing. They're going to give you a graph of a line. If the line goes to the origin, it's a direct variation. If the line doesn't go to the origin, it's not a direct variation. So you can see blue line on the left goes to the origin, that's a direct variation. Red line on the right doesn't go through the origin, that's not a direct variation. Call that an indirect variation. Now, the last thing we'll have to deal with is we'll be given an equation and have to determine if it is a direct variation or not. And if we look at something like y equals negative 3/4 x, that is a direct variation because it's of the form y equals kx. Now, meanwhile, a non-example would be something along the lines of y equals negative 3/4 x plus 8. That plus 8 at the end, it's no longer y equals kx. It's y equals kx plus some other number. We'll call it b, which will become clear sometime next chapter. But the idea here is y equals some number times x. That's direct variation. Y equals some number times x plus something else or minus something else or anything else. We can't have that as a direct variation. We call it indirect variation. All right, we're going to take a moment here, pause, regroup, go back to parts of this video that were confusing, make sure your notes are good. We'll continue on to the next page in the next video.